Good evening all. Am I audible? Good evening all. Am I audible? Yeah, okay. Yeah. Good evening all. I warmly welcome you all to my session. So in yesterday's class we have just made the code, but I didn't to I failed to make the connection, right? So today first let's see the connection. Is it visible? Is it the screen visible? Okay. Shall we start the class? Okay. So first let me connect the LEDs. So this is our, let's take this as LDR LED. LDR LED pin number is D3, right? So D3, and the negative side of the LED has to be connected with the ground. And this is our IR LED, and it has to be connected with pin number D2, and the negative side of the LED has to be connected with ground. So here it is. Then LDR sensor. So first 3 volt and then ground, and then the output pin has to be connected with, what is our LDR pin number? D6. So it has to be connected with D6, which is here. So yeah, okay. So I just place it here. So then IR sensor. So the positive side has to be connected with 3 volt, which is here. and the negative side has to be connected with ground, which is here. And the digital output pin has to be connected with, so what is our IR sensor number? D5. So here it is. Okay. So now let's upload the code. Make sure that you have connected the correct board and the particular port. Here, which is component 4, right? Let me check the port first. Yes, component 4 is available here. Why it doesn't show here, I don't know. Guys, wait a minute. Let me check the port first. Oh. Guys, I'm sorry for the delay. Let's wait for a few seconds. I'll correct it. Oh God. This is not the correct port actually. It's supposed to show like component 4. Let me wait first. Let me try to upload it. Yeah, thank you all for your wishes. No connection established. Guys, wait for few seconds. I will change the USB cable. So there is some issues with my port. I don't know what it is. I have changed the USB cable, but it doesn't support. Wait. So I'll try to solve it in tomorrow's class. I'm really sorry for this. I don't know why my port doesn't work. I think there is some issues with my USB cable. So now let's move to the today's topic. I'm really sorry for letting you wait. Okay. So today's topic is interfacing PIR sensor with ESP8266 using interrupts and timers. So here we are going to interface PIR sensor with ESP8266 using interrupts and timers. So now I will show how to use interrupts and timers with the ESP8266 node MCU using Arduino IDE. So interrupts allows you to detect changes in the GPIO state without the need to constantly check its current value. With interrupts, when a change is detected, an event is triggered, which means a function is called. So here we will detect motion using a PIR motion sensor, which means when motion is detected, the ESP8266 starts a timer and turns an LED on for a predefined number of seconds. So when the timer finishes counting down, the LED will automatically turn off. So let us start with an interrupt first. So first, ESP8266 interrupts. So interrupts are useful for making things happen automatically in microcontroller programs and can help solve timing problems. So with interrupts, you don't need to constantly check the current pin value. When a change is detected, an event is triggered, which means a function is called. This function is called interrupt service routine, which is ISR. So when an interrupt happens, the processor stop the execution of the main program. So when an interrupt happens, the processor stop the execution of main program to execute a task and then go back to the main program. So this is especially useful to trigger an action whenever motion is detected or whenever a push button is pressed without the need to constantly check its state. So to create an interrupt, we have to call attach interrupt and pass as arguments the GPIO interrupt pin, the ISR, which means which function to be called, and mode. So the ISR function must have the I cache RAM ATTR attribute declared. The mode can be changed, the mode can be rising or falling. So the syntax is attach interrupt. So inside as an argument, you have to pass digital pin to interrupt. Inside the bracket, you have to mention the GPIO pin, ISR, and its mode. It can be either change, rising, or falling. So first one, attach interrupt function. To set an interrupt in the Arduino IDE, you have to use the attach interrupt function that accepts this argument. So the GPIO interrupt pin, the name of the function to be executed, and mode. I am talking about the argument inside. GPIO interrupt pin, the name of the function to be executed, which is ISR, and the mode. So coming to GPIO interrupt pin, the first argument is a GPIO interrupt. You should use digital pin to interrupt. Inside the bracket, you have to mention the particular pin to set the actual GPIO as an interrupt pin. So for example, if you want to use like GPIO 14th pin as an interrupt, you you have to give like digital pin to interrupt. Inside you have to pass 14. So the ESP8266 supports interrupt in any GPIO. We have already talked about this, right? So except GPIO 16 because it is a pin which is D0. Then coming to ISR, which is interrupt service routine. The second argument of the attached interrupt function is the name of the function that will be called every time the interrupt is triggered. So the ISR function should be as simple as possible. So the processor gets back to the execution of the main program quickly. So the best approach is to signal the main code that the interrupt has happened by using a global variable and execute code. So ISRs need to have iCache RAM ATTR before the function definition to run the interrupt code in RAM. And then coming to mode, the third argument is the mode, and there are three different modes. One is change, one is falling, and another one is rising. So to trigger the interrupt whenever the pin changes value, for example from high to low or low to high. And coming to falling, for when the pin goes from high to low. And for rising, it is to trigger when the pin goes from low to high. So here we will be using the rising mode because when the PIR motion sensor detects motion, the GPIO it is connected to goes from low to high. So this is all about the interrupts. Is it clear? Shall we move to the timer topic? Is it clear, guys? Shall I move to the timer topic? Okay. So here ESP8266 timers. Here we will use timers. We want to LED, suppose we want the LED to stay on for a predetermined number of seconds after motion is detected. Instead of using a delay function that blocks your code and doesn't allow you to do anything else for a determined number of seconds, we will use a timer. So delay versus millisecond. So the delay function accepts a single integer number as in milliseconds. We have given in the pre-programs, right? Like 2000, 1000, which is milliseconds. So program has to wait until moving on to the next line of code. So delay time in millisecond, when you call delay of 1000 in the sense, your program stops on that line for 1 second. So delay is a blocking function. So blocking function prevents the program from doing anything else until that particular task is completed. So if you need multiple tasks to occur at the same time, you cannot use delay. For most projects, you should avoid using delays and use timers instead. So using a function called millisecond, you can return the number of milliseconds that have passed since the program first started. So for that purpose we are using millisecond. So now let's move to the coding part. Let's see the code for blinking an LED using millisecond without delay. So today I can't interface any components because my USB cable doesn't work. I'm going to just explain the program for your understanding. few seconds. Is my screen visible? Okay, it took so much of time. So okay, let us write the code here. Let me erase it. I will explain the code only here. So first, what we have to do is we have to mention constant integer LED pin. So here I am going to give like D5. So then what we have to do is we have to initialize a variable called LED state. Here I am going to give it as low. So LED state used to be set the LED. Now I am going to store the last time LED was updated. So which is unsigned long previous millisecond, which is equal to 0. I am going to give it 0. So generally you should use unsigned long for variables that hold time. So the value will quickly become too large for an integer to store. For that purpose, it's better to give unsigned long. So then constant long interval, here I am going to give 1000. So at interval at which to blink, like milliseconds. So now coming to void setup. First I am going to set the digital pin as output. So using pin mode function, inside I am going to give LED pin, which is declared as output. So that's enough for void setup. And then coming to void loop, inside first I am going to store millisecond in a current millisecond variable. So for that again I am going to give unsigned long current millisecond equal to, I am going to store this millisecond function. So and then I am going to subtract the previous recorded time from the current time. For that I am going to make a if condition. So if condition, inside I am going to give current millisecond, so I am going to subtract it with previous millisecond. So previous millisecond greater than or equal to interval. So inside the if condition I am going to give previous millisecond, which is equal to, I am going to store the current millisecond in the previous millisecond. So now the program updates the previous millisecond variable to the current time and either turns the LED on or off. So is it clear? Are you guys able to understand this? So just if you guys understood in the sense, just type yes in the chat box please. Then only I get to know. So now I am going to make another if condition for LED. If the LED is off, I am going to turn it on. For that I am going to make a if condition. So inside I am going to give LED state if it is low, in the sense I am going to make it high, else it has to be low. So after else, digital write, here I am going to give the LED pin and LED state. That's it. So okay, let me explain it from the scratch. Okay, I will repeat it. So first, here we are writing code for blinking an LED using millisecond without delay. Okay, so for that first time mentioning here the LED pin. I am taking the pin D5. So then I am creating a variable called LED state, and the LED state is used to set the LED. For that I am in the starting I am giving us low. First my LED has to be in low state. So then now I am going to store the last time LED that was updated. So for that I am creating unsigned long previous millisecond. So let's give 0. So generally you should use unsigned long for variables that hold time, because the value can be quickly become too large or it's become too short for an integer to store. So it's better to make it as unsigned long. So I am constant long interval at which to blink. So here we are going to give 1000, which is 1 second. So inside void loop you just have to mention the pin and its mode. Here we are using LED only. So LED pin, which is output. So coming to void loop, first here I am going to store the millisecond in current millisecond variable. So I am creating a variable here called unsigned long current millisecond. I am going to millisecond in this variable. So and then I am going to subtract the previous recorded time from the current time. For that I am making a condition called if condition. Inside I gave current millisecond minus previous millisecond, which is greater than or equal to interval. So inside I gave previous millisecond equal to current millisecond, which is, so now the program updates the previous millisecond variable to the current time. It either turns on the LED or off the LED. So for on and off purpose we are creating another if condition, which is for if the LED state is low, LED state is low, I am going to make my LED status high, else it has to be in low state. At last digital write LED pin and LED state. So it sets the LED with the LED state of the variable. So this is our program. You just have to connect your LED to D5 pin and the negative side has to be connected to the ground. If you upload the code into your microcontroller, in the sense your LED will blink for every 1 second. So normal LED blinking program, but here we are using millisecond, not delay. Is it clear? Is it clear, guys? Shall we move to the next topic? Here, because this snippet is non-blocking. Any code that's located outside of that first if statement should work normally. So you should now be able to understand that you can add other tasks to your loop function and your code will still be blinking LED every 1 second. Okay. So we have already seen the interrupt topic and then we have seen timer topic. Now we have to move to the sensor, which is PIR, motion sensor. So again I am going to explain the code. So first, before that, let me explain the PIR sensor first. So what is PIR sensor? Here, PIR sensor means passive infrared sensor. So, a PIR sensor is an electronic device that can detect infrared radiation which is emitted by living beings or other objects. So, it is called a passive sensor because it does not emit any energy of its own like IR sensor, but instead detect the radiation emitted by other objects in its field of view. So these sensors are commonly used in motion detection applications such as burglar alarms, automatic lighting systems and smart home devices. They are able to detect the movement of people or animals by sensing changes in the infrared radiation in their environment. So the sensor consists of two halves that detect infrared radiation. When an object such as a person passes in front of the sensor, it will detect a change in the infrared radiation and trigger an output signal to activate the alarm, light or other device, something. So PIR sensors are simple, reliable and low cost devices that can be used in a variety of applications where motion detection is required. They are also used in outdoor lighting systems and like security cameras and other applications. So where energy conservation is a priority, as they can activate only when necessary, it's saving energy and reducing cost. So this is all about PIR motion sensor. So now let me explain the code. I have already the code here. PIR sensor. So first, define time seconds of 10. So first we have to define the timer seconds because here we are using interrupts and timers, right? So for that first we have to define the timer seconds. Here I have mentioned 10. You can modify the number of seconds. The LED is like after detecting motion. It's your choice. Simply change the time seconds variable with the number of seconds you want. So now what I am going to do is that now I am going to assign 2 GPIO pins to the LED and motion sensor variable. I have taken D6 as an LED and D5 as the motion sensor. So then we have to create variables that will allow you to set timer to turn the LED off after the motion is detected. So for that I have created here unsigned long now equal to, now is the variable name. So here I am going to store the millisecond. So the now variable holds the current time now. So then unsigned long last trigger I have given 0. So this last trigger variable holds the time when the PIR sensor detects motion. So for that purpose I have created the last trigger variable here. So then boolean start timer false. I have given false here. So the start timer is a boolean variable that stores the timer when motion is detected. So now what we are going to do is that we have to create a ISR, which is interrupt service routine. This. So first I have given I cache RAM attr. If you are creating ISR in the sense you want to store it in a RAM in the sense you have to create this function. So then I have gave void detects movement. So our ISR name is detects movement. So inside what I am going to do is that if motion is detected in the sense it has to print message like serial print ln motion detected. If motion is detected in the sense our corresponding LED has to become high. So I am making LED high here. So then start timer I am making now it is true, and then I am going the current time into the last trigger variable. So the detects movement function prints the message in the serial monitor first and then turns on the LED and then sets the start timer boolean variable to true and updates the last trigger variable with the current time. We have stored the current time in now variable, right? So we have stored the current time in the last trigger variable. Here we are using embedded C language in Arduino IDE. It is Arduino based and the language is embedded C, not Python. And then coming to void setup, for communication purpose, first I started with serial begin. The baud rate is 9600. Then I am making my sensor as an input because we are going to read data using sensor, right? So motion sensor, which is input. To set the PIR sensor pin as an interrupt, here it is. As an interrupt, we have to use attach interrupt function to, as described, I already told about it earlier, right? So attach interrupt. Inside I have given digital pin to interrupt. So here you have to give the GPIO. Our GPIO already mentioned here. So motion sensor, here it is, and then your ISR name, which is detects movement, and then mode. Here we are using rising. So now the LED is an output whose state started low. Then coming to void loop function. First what I am going to do is I am going to store the current time in the now variable. So the loop function is constantly running over and over again. So in every loop the now variable is updated with the current time. So now I am going to give the if condition. So if start timer and symbol now minus last trigger is greater than time seconds into 100. So this time, the starter time variable is true. So when the time defined in seconds has passed since motion was detected, the following if statement will be true, right? So then it has to print like motion stopped, and then I am making my LED low. Then again I am set the start timer as false. So the motion stopped, message will be printed in the serial monitor, the LED is turned off and the start timer variable is set to false. That's our code. That's it. So here we are just going to interface PIR sensor with ESP8266 controller, which is the pin number is D5. So you have to connect the LED's positive side to D6 and negative side to ground. And in motion sensor there is 3 pin. So one pin is VCC, one pin is ground and another pin is the output pin. So the ground has to be connected with 3.3 volt or 5 volt, and the ground has to be connected with ground pin, and the output pin has to be connected with D5. So this is our hardware connection. If you upload your code, in the sense you can get the output. So is it clear? And I forgot to told one important thing. Note that PIR sensor should be powered with at least 5 volt. It doesn't support 3.3 volt. So if you are using ESP8266, in the sense you have to give the positive side of the PIR sensor to V in pin. Don't give the positive side of the pin to 3.3 volt. You doesn't get any output. So connect it to the 5 volt, which is V in. Is it clear, guys? So this is all about interfacing PIR sensor with ESP8266 using interrupts and timers. Is the code clear? Are you able to understand it? Shall I move to the next? Okay. So it's 5th day, right? So today you're supposed to get your first assignment. So first assignment, in the sense I'm going with a simple task. You have to do a simple task. Okay. So what you have to do is that you have to join with our you can use these two links. You can join either in a Facebook group or you can join in a LinkedIn group. It's your choice. If you want to join in the Facebook group, in the sense you can use this link. If you want to join in the LinkedIn group, in the sense you can join in this link. Because some people doesn't want to join in the Facebook link. So for that purpose you can go with LinkedIn. So it's your choice. You can join in either any one group. So you have to post your assignments there only. If I gave you assignment, in the sense you have to submit your assignments in the Facebook group or the LinkedIn group. Here is the link. Just click it and click join group. That's it. I will provide you the link in the chat box. Use that link, you can join in the groups. If you find any difficulties, in the sense you can ask me. Yeah. Use these links to join the group. So what's your first assignment is, you have to write a code for the same thing. PIR sensor interface with ESP8266 using interrupts and timers. Just now only I explained the code, right? So you have to work with your own. Just try to code and just took the screenshot and send the code, verify it. If you have the hardware or PIR sensor ESP8266 controller with you, in the sense you can record the video or you can send a picture of the output also. If you don't have components, in the sense just write the code and took the screenshot and paste it in the group. I will give you 2 days time. Monday you should submit your first assignment. Monday I will provide you Monday or Sunday I will provide you a Google form. There you have to paste your submitted assignment link over there. I will tell you about the Google form in Sunday's class or Monday's class. Are you clear about the assignment? Do you have any doubts regarding this? Use this link to join the group. You can join either Facebook or LinkedIn, and then do this assignment and took a screenshot and go and post it in the group. Sunday I will provide you the Google form. If you post the assignment in the group, in the sense in the corner there is a 3 dot, click that and you will get like copy link. Just copy the link and paste it in the Google form. I will go through all your assignments using that form. Is it clear? Do anyone have any doubts regarding this? So this is all about today's session. If you all are clear in the sense, let's wind up it here. Do you have any queries or do you have any doubt regarding this? Drop your replies in the chat box, please. Okay. Here I am providing two links. One is Facebook group and LinkedIn group. If you want to join in the Facebook group, in the sense, you can use this link. If you want to join in the LinkedIn group, in the sense, you can go for this link. Just join either any one group. Whether it is Facebook or LinkedIn, it's your choice. Join in any one group and this is your assignment. So you have to write the code for PIR sensor interface with ESP8266 using interrupts and timers, which I have explained before. So try it by yourself and took the screenshot of the code and send the assignment to this link. That's it. Is it clear now? I have provided the link in the chat box. So you have 2 days time. Monday you should submit your, within Monday you should submit your first assignment. If you have components within your hands, you can also try it out and share the output in the chat box. Sorry, in the group. So this is all about today's class. Let's wind it up here. Let's catch up at tomorrow's class. Thank you all. Thank you everyone.